Solve the following systems of equations. Enter the solutions as ordered pairs in the form xy. So here we have two equations. They're both y equals, which means we set them equal to each other. Then solve. So I'm going to take negative 4x minus 3 just because it's smaller and move it up. You could do it the other way. Either way, you're losing the y's and you're putting the two variables or the two equations next to each other, and that gives me one variable to solve for. I'm only solving for x. So now I have an x squared, which is a quadratic equation, and before I can do anything, I have to get it set equal to 0. So I'm going to start combining like terms here. I'm going to add 4x, and I'm going to minus 3. So I have 0 equals x squared plus 9x, and then 21 minus 3 is 18. And they're giving us really nice ones to factor here. So I'm going to factor. You could use the quadratic formula, but because we're looking at just 18, so I have 1 and 18, 3 and 6, 2 and 9. Which one of those will add to 9? Can you see it? I hope so. Positive 3 plus 6 is positive 9. And these go in our factors. So x plus 3 and x plus 6. And now the equal 0 is huge. We need that equal 0. Because now we set each factor equal to 0 and solve. So x equals negative 3. And x equals negative 6. And remember, those are our two values, and we need the y values. So I'm going to go back up here and pick the easier looking equation, which is y equals negative 4x plus 3. There's not an x squared. Plus 3 or minus 3? Plus 3. And we're going to enter this x value. And first we're going to do negative 3. Then we're going to do negative 6. I don't know why I wrote negative 3 there. We're finding the y value. So y equals negative 4. And then I'm going to substitute negative 3 plus 3. So that's 12 plus 3. So y equals 15 right here. Negative 3, 15. Now we're going to do the same thing with negative 6. Negative 4, substitute for x, negative 6, plus 3. Negative 4 times negative 6 is 24 plus 3, which is 27 here. So negative 315 and negative 627.